in respect to x. Or if you transpose EI to the other side, it could be the ratio of M and EI is equals to the second derivative of y with respect to x. So we can actually take advantage of this formula. No, this is taken from this is a classic equation starting from the probable of rigid bodies. No, I just uh, get this simple equation and use this as a basic equation. So we can have this equation, which is our well, siya, o kickboard sa double integration method. Okay, so this equation will become like this. Okay, so we have here y. Actually, if we are just trying to integrate both sides of the equation, so integrating the left side of the equation, the second derivative of y with respect to x will be equal to y. While integrating the other side will be integral of m over ei dx plus ax plus b. No? So a there and b are constant of integration. So that is the reason why this is called double integration method. Okay. So actually, this is very easy to use. No, I consider this as one of the method in determining deflection of beam. You can particularly determine the deflection at any point within the beam. So what you will do here is procedure. No, procedure. We'll make this into a procedure so that we can procedure. Okay. Okay, so draw the load diagram, no? Load diagram of the loaded beam, loaded beam, okay, loaded beam with external forces. Okay, so that's it. The second, the most important is determine the moment equation. Moment equation of as a function of x, no moment as a function of x. Capital M, and we have here that means it's a function of x. For 0 is lesser than L is lesser than x is lesser than L, no? So dapat mo na ang entire length ang imong range. Okay? So actually I have here two sub procedures. So number one. So we have the basic equation, and then to determine the equation, just integrate. So we will proceed directly to example. So example, we will start from the simple example. Say one, simple one. Okay. So this problem is determine deflection of beam at x equals to 4 meters. Deflection of the beam of the loaded beam at x equals to 4 meters. Let's just say EI is constant of the member throughout the length of the member, meaning it's constant. Okay, so the figure looks like this. I am just going to draw, but the problem here is it could be a challenge to draw. Okay, anyway, I can do a lot later. Okay, this is the beam. What will I do is I will just change color. That's the beam, format object. Then I will change the color and size so that it will really appear as beam. Okay, so the line is, yeah, that one. And then the color, I change that black. And then the size may be a lot bigger. Okay, so that's the beam. And I will make a reaction. Okay, the reaction here is the internal force. I'll just make this big. I'll just make that big. Maybe big. That one. Yeah. And then I'll just color it maybe black. Okay. And then I will copy this to the other side. Boom, copy. This will be the reaction also. Okay. Okay. That's the reaction. And then this beam is, I will say that this is 10 meter long, 10 meter long. And then there is a load here at the middle. Home, copy, paste. There is a load here in the middle. Okay. And that load is, you see that is 50 kN. Kasi sibo gamay. Okay. So, muna siya. Ang ano? Balitag 5 meters na siya. 5 meters. 5 meters. So, this is the problem, no? We have here a loaded beam with constant cross-section all throughout and made up of only one material. So, that is what we mean by EI is constant throughout the length of the member. The length of the member is 10 meters all in all, no? So, the 5 meter here only the length from the lip support to where the concentrated load is applied, and the other 5 meters is from the midspan going to the right support. So the total length is 10 meters. We are going to determine the deflection here. So if I'm going to do the deflection, I can superimpose it here. No? Superimpose it here. So I can use curve. Yeah, I can use curve this one. Okay, that's the deflection, and then maybe I can change that into like that, and maybe color red. Okay, so that's the deflection. So this one is the deflection of the beam throughout the length. But the problem only states that you are going to determine the deflection at x equals to 4. So x equals to 4 meters is somewhere here. So this is what you are going to determine. That's the length of that. No? So you are basically determining y equals to 4. So a bit, no? So procedure 1, if you are going to follow procedure 1 here, that means you are going to determine the load diagram of the beam with external load. So this one is not complete because there are no reactions. So we will convert that into P1, no? Meaning procedure 1. Next is P2. P2 meaning procedure 2. Okay? So if you are going to determine P1, so I will for this one, group that. Okay, and then maybe copy that, and then paste that here. So procedure 1, so in procedure 1, you have 50 key in here, 50 key in 50 and then here you will have something like 25 TN because the load is actually uh, 50 going down, so there are little reaction, and then the load is symmetrical, so you don't have to compute it by submission of moment. We just use our common sense that if the load is symmetrical, then the reactions are equal. So 5 meters here, this is also 5 meters, and then this is another 25 TN. So that is what we mean by one. And then we are going to determine the equation, no? The equation. So uh, I'd rather make an equation, a cutting line somewhere here, no? So that I can make an equation. So I can make my cutting line here. Okay. Cutting line. Okay, we'll just copy this one. Copy that one. Oh, copy this. Then I'll put that here. So copy it here. So okay. So that is my cutting line. No, meaning I'm holding a katana. I will cut it here, not here. Okay. So I will tell you the reason later. No? So what happened is that this is my X. This is my X. Okay. That's my X. Okay. Now the this is now the what appears if you are going to do the load diagram with external forces. So okay. Now what I just added is the blue line, the cutting line. Okay. Now I cut somewhere here, not here. Okay. The reason is that if I'm going to cut it here, my equation of moment will be only up to here because uh, that's only where can you have a uniform function. If you go further here, the function is somewhat disturbed by this concentrated load. So between this point and this point, if this is my starting point here, I'm going to the right. So I'd rather cut somewhere here, no? Because going further, there is no chance of loading, no? Because 25 kilonewton is an upward force and happen to be at x equals to L. Okay? X equals to L. Remember that my equation should be for 0 up to L. Dapat mauna ang imong equation. Okay? So, for example, if I'm going to cut it here, no? If I'm going to cut it here, okay? So, my x is only up to here. Okay? Now, if I go, there is still one load that is blocking as you go, as you move your x up to this point, and this kind of load is a disturbance to your equation. Okay, because it's not considered here. So if you go from this point to this point, you are going to pass by this load. This is a disturbance. So meaning that if I'm going to write an equation, it would be only up to this. So if I'm going to actually put my cutting line here and make this as my x, that means that I have already considered 50 kilonewton in my equation. And going further from this point to the other point, there is none. There is no one will obstruct. Okay. There's 25, but 25 happens to be at x equals to L. So it's not really of important. Okay. So that means that I can write my I can make my one here. I can make my moment equation from there. So from there I can make a cut. Okay, I will cut and then paste here. So if I'm going to make the right side of the equation, this is it. This is what happened to your right side of the equation. Okay, right side of the equation. So I can have an x here, and I can, okay, so this is now the figure that I am cutting. No? This one. Insert. I'll just use this. Okay. So I use the right, not this one, not the other one, no, not this one, but this one because this is where my x is located. So that's why it's only show the portion of this, no portion of that. So I can have my equation here. So I can insert another shape here. Maybe I'll just use this one. Okay. So I can make an equation there. I will make an arrow. Okay, an arrow that looks like this. Then, okay, as I get an arrow, I will copy another. I think this one looks like an arrow now. No? You have this one. That one. That one. That one. There you go. Okay. Okay. So I have now an arrow. No arrow. So that one is basically representing the moment. Okay. So I'm going to that represents the moment. Moment. Moment as a function of the. Okay, I remove this one here. Okay, so I will put moment here. Moment as a function of the x for this one. Okay, moment as a function of the x. One. Okay, so procedure two is you write a moment as a function of x. So summation moment at x, no? So I sum up moment at x. So I will change this into a symbol. Okay. Now I will just say positive counterclockwise. Okay. So looking from the diagram here, this moment here is mx, and that rotates in a clockwise direction. So that's why it has a positive sign. Okay. Another positive sign is you have the 50 kilonewton, no? Let's say the 25. The 25 is will rotate about x, no? This will be your pivot point. So if you try to determine where the 25 kilonewton rotates, it rotates in a clockwise manner. So it could be negative. So that's 25 times x, no? 25x. Ini siya, ito na ni butang subscribe ko x. Subscribe na siya kay maka kuan nga kasi kay mga multiplication na. So 25x Then there's another one that will cause moment, the 50. So you'll have 50 rotates in a counterclockwise manner, no? About this point X, no? 50, but the moment arm is X minus 5. Okay. And that is equal to 0. Okay. Okay. So this is the moment equation actually, no? But the one under the parenthesis, which is x minus 5, do not say trick. If the value inside here is negative, if the value inside the parenthesis is negative, consider it as 0. Okay, why? So it's just like you are born in year 2000, and then your age is negative 5, so that's roughly 1995. So that means you do not exist pa. So you might as well as put yourself 0, no? So that means that for the value inside the parenthesis ni lesser than 0, meaning there is no, that load is not yet, is not yet exist, no? That it there. Okay. Like for example, at x equals to 3 here. So in between x equals to 3, that 50 kilonewton load is nowhere to be found. At at x equals to 2, so 2 minus 5 is negative 3. So at x equals to 2, that 50 kilonewton does not exist. But when you say x equals to 6 meters, so what happened? X minus 5 equals positive 1. So that's somewhere here. So 50 is already there. Okay. So that's it. So far, this is P2. Then go back to the equation of this one. This one. So you'll have d squared y, d squared y over dx squared is equals to in over ei, in over ei. Okay, so this one is to be there, there. Okay, that's the equation, no? Taken from this. Okay, baliktad lang ako. So that means that this one is smoothly na siya. Okay, and then I will copy that again here and paste that. So this will become, ako lang siyang 1 over EI na lang siya. 1 over EI because moment is already that one, no? So if I'm going to express the moment equation, that is equal to 25x minus 50 times x minus 5. So here, you will have a term 25x minus 50 times x minus 5. Okay, this is now our working equation. So, if I am going to integrate, what will happen? Okay, what will happen? That's the question. What will happen if I'm going to integrate that? Okay, so if I'm going to integrate the squared y dx squared once, it will become dy dx. Okay, integrating once. So mawala ang yung superscript na 2 kaya mo naman siyang integrate. So, kita may mo na siyang 1 over EI, and we have here the integration of 25x will become 25x squared, no? And then, ano siya ay divided by 2, okay? Then, you will have also minus 50, ini siya, may mo na siyang x minus 5, ano siya squared divided by 2 yapon. Okay? Now, we do not actually put constant of integration because we have limits. We have limits. Okay. We will put at x equals to 4. Okay. No. Okay. So, na constant. So, tana to C. Okay. Now, ato sa ning ayuson, kini siya may muna siyang subscript. Kini siya din. Okay. Kini siya may muna siyang subscript. Okay. Okay. Class, if you compare actually, this from the above equation, this one is just after the above equation is integrated once. So pag integrate sa d squared y dx squared naman na siya dy dx, pag yun siya, function of x man, ang integration sa function of x will be x squared divided by 2. Okay, the same the one inside the parenthesis, that is that one. Okay. Now, we can get rid of c if you say at x equals to 5, we can have dy dx, or the slope is equals to 0. Okay. Why? Because right here at x equals to 5, if you are going to draw tangent line at x equals to 5 meters, that is at the midspan. And then at the midspan, that is the lowest point, no? So meaning that if you draw tangent line to the lowest point, it will just be a horizontal line. So let me draw it, no? It will look like this. Okay, if you do a tangent line, this is a tangent line at the lowest point. Okay, it will just be a horizontal line. Okay, you have to be creative actually, no? Why you choose 5, because you know that dy dx equals to 0. Dy dx is the slope. This is what you call the slope. So if you substitute that, it will be 0 is equal to 1 over EI, 1 over EI times, you'll have 25 times 25, 25 times 25 is equal to 25 times 25 divided by 2, that will be 25 times 25 divided by 2 is 312.5 minus at x equals to 5, the quantity inside the parenthesis is 0, so you'll have minus 0 plus, you'll have plus c. Okay, so we can have a c here. C equals to negative 312.5 over EI. Okay, over EI. That's the value of C. Okay. So we will write again the dy dx here is equal to 1 over EI times 25 x squared minus 2 minus 50 x minus 5 squared divided by 2, and we have minus 312.5 over EI. Okay, we'll put that one here. This is here. Or maybe we can put that one, but we will inside the parentheses, but factor EI to the other side. So that's it. Now, if we want to determine the Y again, so we have to integrate this. So we have this is now the second. This is now the second integration that we perform. Thus, this called is double integration method. Okay, we can have Y equals to 1 over EI. Okay, what happened to the X here? This is squared actually. Okay, this will become 25x cubed divided by 6 minus 50 times x minus 5 cubed divided by 6 minus 312.5 times x plus okay, now let me say plus c again, no, c. It's another constant. This is not the C. I will just name this as C1. C1. This one is C2. Okay. Okay, so this one we have to ayun sa nato to equation. Ano siya? Okay, y. Now to determine C2, so you have to add x equals to 0, y is 0. Y, okay. At x equals to 0, somewhere here, y is 0. There are 2 points in which y is 0. One is at x equals to 0, and the other is in the other side, at x equals to 10 meters. Okay. We are not going to use the 10 meters because it will be messy in the equation, so 0 is neat. No? So what happened is that if x equals to 0, you will have 0. 0 is equal to 1 over EI multiplied by the function of x, so that's 0, minus 0 again, minus 0 again, plus C.
Sir, may I have a question, sir?
Yes, yes.
Sir, kanin sa integral nga over 6 ba, di ba? N plus 1 man na, sir?
Yeah, in plus 1, that will become 2 plus 1. What is 2 plus 1?
3.
Then we have 2 already in the other side, in the denominator. So that will become 2 times 3.
Okay, sir. Naman.
Okay? So, matingala bitang mo ano 6, no? Yeah, because na naman ko kay 2 daan. Yeah, kung tama pa rin mo nag-n plus 1. So, n plus 1 is equal to 3, right? Because n equals to 2 percent 3. So that will become 2 times 3. So the same also on the other side. So I hope, kuha na rin muna, no? So here you have the equation here equal to this. Okay? So then you go to the problem at x equals to 4. So at x equals to 4, y is equal to y4. No? Y4. So ano ito na subscript? Sipan na. So you will have y4 is equal to 1 over EI times 25 times 4 cubed divided by 6 minus 50. 4 minus 5 actually is negative, so you will have 0 here. Okay? Cube. Okay, ingon man nga, basta negative galing inside sa parenthesis, is 0 na siya automatic. Divided by 6 minus 312.5 times 4. Okay? This one is a cube. So you will have equal to 1 over EI times we have 4 times 4 times 4 times 25 divided by 6 minus 312.5 times 4. We have minus 93 na lang, 983.333. Hindi natin butang minus. Okay. So that's the answer. No? That's the answer. Okay. So actually, the technique here is in determining the moment, no equation. Okay. You have to be one in moment. Actually, there are many ways of determining moment equation. This is only my the style that I teach, you know. So I want to gusto na ako nga dinhi ko mag-moment para wala na lain nga load nga makasagabal, no? Kaya sa gabal mo ginang load mo, usab ang moment nga equation nimo kung motabok ka og line loading. Now, kung dili ang imong x, so dili nimo ma-express uniformly ang equation throughout the length because you're still passing the 50 kilonewton load. So to solve that problem, you have to consider it in your equation. Okay. So that is how you do it in double integration method. It's really mathematical one. But that one will help you. No? That one will help you. Okay. So what about this one? Okay. So if you have this one, ah, uh, let us say at x equals to, problem is at x equals to, we'll have another problem. What is the deflection at x equals to 6 meter? Okay. So here, kita ni mo din nga mauni siya ang y4 ang 6 sa 6 meters siya din. Kung sa ka ang value sa y sa 6 meters, parehara ba ka sa y equals to 4? So, what do you think, class? Ang sa 6 meters ug ang sa 4 meters sa solve na nato unsa ka ang sa 6 meters? Any answer?
Equal na sa force.
Equal ra, no? Kay symmetrical man, no? Ang parabola, symmetrical man gid siya, di ba? Yeah, uniform man ang iyang size sa beam. So, there's no reason nga na dili uniform ang iyang curve. But we have to prove that here in the equation. So, at y equals to 6, we are going to use this, no? We're going to use that. Okay. But which is this equals to 6 meter. And then this one will become 6. And then we have here y equals to 6. Ang kuan lang is kini listen to 6. Kaya kini siya dili na 0, we have 6 minus 5 is becomes 1. Then kini siya may mission 6. Tanawon daw na ito kung pareha ba. Tanawon na ito. 6 times 6 times 6 times 25 divided by 6. 900 minus 50 divided by 6. 891 minus 3124 5 times 6. So, iharaman, no? Okay. If this is my question, what is the deflection? Okay, right. We have shown that the deflection at 4 meters and 6 meters are the same. Okay, by substituting x into the equation. So another question, no? Still 15 minutes away. What if it is 2 meters? Will it be lesser than the deflection we got from 4 meters? We'll analyze it from the depicted structure. No? So up to meters somewhere here. So lesser siya sa value sa deflection sa y equals to 4. Of course, no? Lesser siya. Yaman din dapit. So, akong kopya ko ni ayun na lang. So, y equals to 2 meter. So, what happened is that you copy this, copy, and put that here. So, may mo na lang niya siyang 2. So, this one will become 2, not 6. This one will become 2, not 6. Then, kini siya, 2 meters na siya, 2. Kini siya, 0, ni siya. Kaya nga naman, ano man, negative man siya sulod. Now, ang equation is x minus 5. So, 2 minus 5 equals to negative 3 man siya. So, kung negative gali siya, 0 siya. Kini siya, dili siya. Kaya dili pa ni minus. So, 2 gid siya. Okay. Let us see kung gamay ba siya sa 93. No? You have 2 times 2 times 2 times 25 divided by 6 minus 312.5 times 2 and minus KDI, no? The answer is 591.6. That's how you are going to obtain deflection by one. So, for your own, determine the deflection at x equals to 4 meter and 7 meters for the loaded beam shown. Okay. So, sa may loaded beam shown is kini ako yung kopyahon. Okay. I-home, copy. Okay. So, gawas pagitaan na napag dito idugang load line. Ini insert na siya o shape. Gawa natin siya din line. Okay. So, mga siya, no? Ini siya, butang din siya o 100 TN. Din siya o 20 TN per meter. Okay. Ini siya is 5 meter. Isibog na ni. Ito siya. Ano lang siya. Paano siya? 5 meter and then this is another 5 meter. So, this is your problem, no? So, this can be your laboratory works. So, submit next meeting. Okay, that will be March, today is March 4, we 11 na, no, delay. 11 is Thursday, Wednesday, Tuesday, March 9, today is March 4, 5 of March, 6, 7, 8, March 8, March 8 ba man di class?
Yes, sir.
Yes, sir.
Okay. So, when you determine the deflection at X, so EI is constant. You see EI is constant. So, use the two procedure method, no? P1, P2. So, first you solve the reaction. Then second is determine the moment equation. Now, if you start X from the left, going to the right, be sure to cut somewhere here. So that all the two loads are considered. Because if you're going to cut it here and your X is here, wala pa rin mo na-consider ang load. So, pag abot sa imong X din mula pa sa 5, uy, na anaming nakasamok. So, kini nakasamok, i-include na lang ni mo daan siya. No? Ayaw yun na siya i-ignore. No? I-include yun mo na siya. Okay, hindi mo na siya i-ignore, abi ni mo na get rid na mo siya. But it will still be there when your X is greater than 5. So, it will destroy your equation nga na mo. So, better to cut it somewhere here. So, just like what I did here. Okay. Here that I cut it somewhere here and use this as my free body. Okay. Okay. So first you do the one. This one is, remember, this one is unsymmetrical. So there could be the deflected structure. I will give you. I will give you. The deflected structure base will be like this. Oh, no, no. Give it, man. Tidak mau. Again, dapat yang dirang kuan itu structure. Okay. So dili siya symmetrical, ha? Kaya nga loading bias to the right. So that makes it not symmetrical anymore. Okay. So dili pa ganihan nga ang x y equals to 4, y equals to 6 are equal gini siya dili. So lagi mo siya i-prove dili. So what you will do here is to determine the moment equation and then plug that to your second derivative equation and then solve by double integration. Okay, get rid of C1 and C2 by substituting boundary conditions. What are the boundary conditions here? Okay, I will give you the boundary conditions. You can use this in solving the constant, no? So like at x equals to 0, y is also equal to 0. X equals to 10 meters, y is again 0. There's no way that you can determine that the dx equals to 0. Why? Because you do not know where the slope 0 is occur, no? You can only say that there is a point where the tangent line is 0, and that is the lowest point. But finding the lowest point includes the problem in maxima minima. You can actually do that. No? But with these two, actually, this is enough to solve for C1 and C2. No? So solving for C1, solving for C1 and C2. So you can use this. No? So you submit this on yeah. Next meeting, no? Next meeting. Okay. So then next meeting we will move to another topic using table, no? Because ultimately we have to use table. Okay. Dali yung table, and diretso na ba? I just want you to experience and know how to use this double integration method. So class, that's all for our topic, this laboratory session this morning. No, it's a lot of computation because laboratory is a lot of calculation. If you are analyzing structure, you cannot get rid of calculation. Even if you are using a computer program, you have to understand how the structure will behave within, so that you can use the program. Do not accept the answer right away without analyzing the result. No, you still have to analyze anong yani mo na yung resulta, no? Just like anong negative mo na yung deflection, tanaw din mo tungod kay anong negative to na deflection ni why I get negative 983.ei. It's because tanaw sa nimo sa imong deflected structure ay ubos man di ay ang akong diagram, akong deflected structure wala man siya bisaka. Tungod kay ang load ay mo downward, so dapat may ani gid deflection. So you have to be realistic in determining the deflection. No? So if you get positive, then you will start to question na positive na ito na negative man dapat. No? So that is what we mean by do not accept right away what is the answer. No? Kaya basin o basayop lang ka sa sign and masayop kang sign dako na kayo na sayop sa inyong kuan kung sign in kinalanon. No? Okay, class, do you have some question? Gani, ano na question anong denominator and music? So I already answered it. So basin na pa yung mas malalang ang question na ito. Mathematical naman ito siya. Wala na?
Sir, ako na sad, sir.
Okay ka sab, okay.
Sir, nakapasa na sa draft assignment, sir.
Nakapasa na ka, oh.
Nakapasa ang draft, nagpasa ko before sa deadline, pero wala na ako na submit yun, sir, ba? Pero dito sa e-learn.
Nasa ilan, nakasubmit ka. Kaya kung wala, ako kang i-email nga kulang ko, submit mo sa akong email ko.
Submit na ako, sir, kay pagkita na ako nga wala siya gikuan sa draft.
Sige. Okay ra actually. Kaya actually, kung taon ko na siya, kaya gusto na ako nga, mabutangan gid ang inyong pan ba kay pag-compute niya, I will be computing your grades na next week. So, I will be looking for some kuan wala na kasabit kay posible mo nga no dako kay posibilidad tungod sa signal ga wala no. Ako dinhi I have an experience of kawala ang signal do lagi sa kanat collector na putol. Naputol ang signal na wala gayo ang kuan dai. Kini tawag sila niya sa hanging street. So, ingana ang case ba. So, for that, dili kayo mo ma-worry, no? Basta kay, muna na lang na katulad sa yung iban, yung resulting nag-try mo submit pero na problema. Well, problem is really reality in our country. So, but mine na lang kayo, mostly, no? At least mga 75% is okay. So, like mine. No? So, what is important is that you can submit and try ka, no? Okay?
Salamat, sir. Salamat, sir.
Okay. So, yes, you.
Ay, sa ESS 17, sir, like, when can I take my midterm?
Ikaw si Darapa?
Yes po, sir.
Pakad lang, Miss Darapa, I was preoccupied last week dahil kung mga lakaw-lakaw. In fact, dagang kung mga travels, pag weekend mo, sabi ito ko pagtuko sa akong mother na so I will just you no I will just give I will just communicate with you probably next week and I will just give you a window. I hope just to remark lang kung dili ka available na time ha. Ito na example lang, you will take this 5 o'clock to 6:30. So I will message you. Then just comment if you are not available because you have class. So I'm not going to give you. But if you do not comment, I will open the quiz again for you only.